Hello, everybody. We are going to learn about the layers of the earth. Okay, so the earth is kind of like an onion, and it has layers, similar to how an onion has, but not maybe as many layers as most onions. So the earth is divided into four main layers. First, we have the crust, and that's the part we live on, and it's very, 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 very thin compared to the other layers. Then we have the mantle, the outer core, and the inner core. The Earth's crust is the thinnest layer. Like I said, it's between 5 kilometers and 50 kilometers, depending on where you are. If the Earth was an apple, the crust would kind of be like the skin of the apple. It's that thin, and it's where we live and where all of the life on Earth is. The oceanic crust is mostly made of igneous rock basalt. What in the world does that mean? It means it's made out of lava. So we've got like the mid-oceanic ridge in the Atlantic Ocean. We have other volcanoes on the bottom of the ocean, and they produce volcanic rock, which is very, very dense. It's dense because there's a lot of iron. If you guys remember from the cave, I said that you could tell that the cave had a lot of iron because anytime you have a dark gray or a black rock, it's made out of iron, and rocks with iron in them are very dense. So it tends to have more iron than continental. It's not very thick. It's really thin, but it's dense, and so it sinks, and so it's under the water. It's pretty new because it just came out of a volcano, but it's down there at the bottom. So continental crust is thicker, and it's made mostly of granite. It's an igneous rock, and it's been melted as well, but it's been allowed to slowly cool, and crystals have formed out of it. And if you look at granite has a lot of white in it, usually, and that is silicon. And so it's not as dense, and it's also thicker. So it's found underneath the continents, and it's where we live. It's older than the oceanic crust, usually, and because it didn't just come out of a volcano a couple of thousand years ago, and then and it floats higher. So if you're going to have a subduction zone, the continental crust is going to be on top, the oceanic crust is going to be on the bottom. Now, you're not 100% of it is going to be granite. Like in our area, we have a lot of really igneous black rock that's going to be actually more similar to the oceanic crust. That's okay. It's not 100%, but most of it's in the granite. Most of it's lighter. Most of it's thicker. So the lithosphere is what's called the crust and the very uppermost part of the mantle, and it's what's broken into the plates. The lithosphere is the part that's riding around on these plates with the plate tectonics, okay? And we've got the plates going underneath each other, and the plates carry the upper crust with it. So it's kind of like where the skin meets the meat of the apple, if you're going to think of it like that. It's broken up into plates. So, and this is the part that's riding around on the mantle. The mantle is the part between the crust and the outer core. The deeper you go, it gets more dense, it gets more pressure, and it gets more hot. It's somewhere between 870 and 2,200 degrees Celsius. It is extremely hot, but it's not super liquidy because of the pressure. Remember, just like with water, the higher the pressure is, the lower the melting point is. So the deeper you go, we get more pressure, and so it's going to actually be more solid. The parts of the mantle, the outer part is the lithosphere. It's the crust in the uppermost mantle. So the lithosphere is where kind of the crust meets the mantle, and that's what forms the plates. And then we have the asthenosphere. Boy, say that 5 times fast. Asthenosphere. That is not an easier one. It's the upper part of the mantle, just below the lithosphere, and it's kind of what the plates are floating on. You can kind of think of it like a silly putty layer. It's like the peanut butter. It's like the texture of peanut butter, and it is what is moving that the crusts are riding on. So the asthenosphere is moving, and it's carrying the lithosphere on top with it. The outer core is much more liquid. than the mantle is. It's not that peanut butter consistency. It's liquidy liquid. It's liquid iron and it's liquid nickel. And it's significant that it's iron and nickel because iron and nickel are both paramagnetic metals, which means that they can form a magnetic field. That comes into account later. Iron and nickel are actually the only two paramagnetic metals. You don't get a magnetic aluminum, gold, silver do not align their atoms in the presence of a magnetic field, and they cannot be made into magnets. It is extremely hot. We're between 2200 degrees Celsius and 5000 degrees Celsius. The deeper it gets, the hotter it gets. But it's liquid, it is liquid metal. Okay, so the inner core is solid iron and nickel, but its temperature is 5000 degrees. And you might be saying to yourself, wait a second, Mrs. Barlow, I know that the hotter things get, the more liquidy they get, right? Like you heat up your butter, it turns to liquid. You heat up peanut butter, it turns to liquid. You heat up anything and it turns to liquid. Well, so why in the world would the inner core be solid if it's hotter than the outer core? And the reason is the pressure. Look how many miles and miles, how many kilometers and kilometers of rock we have on top of this. The pressure at the inner core is huge. And it's so high at that pressure that even at 5000 degrees Celsius, that iron and that nickel is solid, even though it's that hot, because the pressure is so high. It's the densest layer. And kind of an interesting fun fact, it spins faster than the Earth rotates. So the core is spinning really fast and the Earth's out here going, doo, 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 doo. Well, that sets up an interesting thing. It makes what's called the magnetosphere. So the inner core and the outer core, I'm going to go back here. The inner core and the outer core are turning at different speeds. So the inner core is turning really fast and there's a lag with the outer core. It's slower and it can get away with that because it's liquid, right? So it causes a generator effect. Whenever you have moving charges, you're going to create a magnetic field. And it's the inner core and the outer core turning at different speeds that produces the Earth's magnetic field. And that is extremely important because that Earth's magnetic field protects the Earth from some of the sun's harmful radiation. So the sun produces a whole spectrum of radiation, and some of it will damage our bodies. Basically, everything that's more energetic than visible light will hurt your body. So all of the gamma rays, the X-rays, the ultraviolet rays, they will hurt your body and they can cause cancer, and they can kill us actually pretty quickly if we're in contact with a lot of them. So we have this magnetic field around the Earth that deflects some of these harmful rays. And also what happens is some of the harmful rays create ozone in the atmosphere, which then absorbs the harmful rays. And so we've got this magnetic field surrounding the Earth that protects us from the sun's harmful radiation. So how do we know? Like, nobody has dug down. You cannot dig to the center of the Earth. It gets too hot. Your drill will literally melt. So here's the cool thing. So an earthquake happens up here, right? And the waves are going to travel all the way through the Earth. But whenever a wave goes from one place to another, like from the mantle to the outer core, or from the outer core to the inner core, the densities of these things are different, and the waves will travel at different speeds. And the different types of waves will travel at different speeds based on the density and what kind of wave they are. And so we can feel this earthquake is over here, and they can feel it clear over here based on the speed of it is based on which layers of the Earth it came through. So they'll feel the earthquake clear over here, and they'll feel it differently than if it was clear over here, because here it traveled through mantle and outer core and inner core, and then back to the outer core and back to the mantle and then back to the crest, and then they feel the earthquake. Whereas over here, it's just going through the mantle to get there. So it really is a very cool thing that they can be able to tell. And the waves are bent when they go through the different densities. And so, so they can tell pretty accurately by reconstructing the path of these waves, what the core is made of, what the inside of the Earth is made of, what those densities are, and what their states of matter are. And there we go. There's where we have the Earth's composition. I hope you enjoyed it as much as I do. Let me know if you have any questions.